For this video, I chose the Digitech wireless doorbell and will be focusing on the front cover half of the product, but also analyze the product as a whole with all of its various parts. The design of the doorbell is aesthetically simple and mostly dictated by its various functions. It is shaped as a compact rectangular prism with overall external dimensions of 80mm long, 38mm wide, and 28mm high. The form factor is small and elegant, making it suitable for any home exterior by not drawing too much or too little attention to itself. The primary function of ringing the bell is achieved by pushing the button on the front face of the body. The secondary function of the doorbell is to send instant feedback to the user that the button was successfully pressed by flashing a red LED for 3 seconds. The button is designed to attract immediate attention by having a dark contrasting color to the white body. Furthermore, the button is outlined with a white housing ring that keeps the button in place. The entire button section is formed in a convex circular protrusion, which also draws more attention to the button and invites the user to press it. This slight offset surface also draws the eye down to the button and gives the doorbell more visual interest. The color of the body is white and has a medium to low gloss surface finish with a very smooth texture. The transparent plate that covers the name tag and LED light is tinted the same hue of color as the button, which makes the face look less empty and more aesthetically balanced. The dark tint also makes the LED more visible in bright lighting. The nameplate is also attractively proportionate to exactly 1/3 the surface area of the face. The unit comes with a strip of double-sided tape on the back plate, so the user can then easily stick the doorbell onto a wall and remove the front body when the lithium battery needs to be replaced. I've identified the body as being manufactured from ABS plastic. This is because it sinks when placed in water and displays typical physical properties of ABS, namely high stiffness and high impact resistance. This material is well suited as an electrical insulator and allows the product to have a water resistance of IP44, which means it can be splashed with water from all sides, making it ideal for outside use. The button is made from silicone rubber and also provides a watertight seal at the front. The backplate can easily be removed by using a thin flat head screwdriver. It is attached to the front half with a standard cantilever snap fit that snaps into the internal undercut cavity. The PCB board with the battery can then be unscrewed to reveal the internal injection molding detail, including 2 bosses for the screws, various ribs to strengthen the part and to hold the PCB board in place, as well as 2 more internal undercuts that guide the backplate and PCB board into the correct position respectively. There are another 3 external undercuts found on the outside of the body. They hold the name tag in place and also provide an opening to detach the back plate from the front half with a screwdriver. The positions of the gates in the mold are easily identifiable on each part and are usually located near the center of the parts for optimal flow. The marks that were left by the ejector pins can also be seen on all parts. On the main body there are 2 obvious ejector marks left on the inside. On the back plate there are 6 ejector marks, and on the internal button part there are 4 ejector marks. I also want to mention that these instructions and graphics were added onto the plastic using the pad printing process. The average wool thickness for the body is 1.7 mm and the draft angle for all surfaces is between 1 and 2 degrees. To form all of the internal and external undercuts in the part, sliders and lifter mechanisms are required that allow side action for the part to eject smoothly from the mold. Since this part has many undercuts, the injection molding machine required is most likely a slide mold, which is ideal for undercuts. To create the screw thread in the bosses, a screw device would have to be used as well. I tried to estimate the tooling cost required to make this part by using an online injection molding price generator. I plugged in all the relevant information and received an estimated price of about 760,000 Rand. This price seems a bit high for me because of how small the part is, but given the part complexity, I also did not expect a low price. I also found a vacuum system that uses vent channels to allow the air in the mold to escape during molding. The simulation shown here has vents integrated into the ejector pins which effectively let the air out. That is all I have for the injection molded doorbell, and I thank you for watching.